So welcome back. I hope Adventure is going well for you. If there's any questions about Adventure, I will answer them. Are there any questions? You can think, and I'll ask again at the end of class. Adventure, it's adventurous. Cool. I have slides prepared for today on Mergesort, which I think is interesting. I think convincing you all that it's interesting while you're back from break and working on Adventure is tough, but I should show it to you, and maybe someday you'll think it's interesting. Also, I just wanted to show you one other thing, or two other things, because they happen to be open on my computer, which didn't shut down over break, so it was in there slurping down electricity, as one is wont to do. So I checked on 11/03, so 28 days ago, I introduced JSON in one of my classes as a way to store graphs, and in this case, this is the graph of the Amtrak Cascades route connecting Portland to Seattle, because you just need an example of something. Since then, I have become extremely into JSON. Lucky you. So now I think JSON is awesome. And in my other class I'm teaching this term, which I'm calling Systems in Rust at CS 271. If you're CS majors, you'll probably be taking it this time next year. If you're not, you should take it anyways, because there's an international studies major and a physicist in there for some reason. We keep asking them why they're there. They won't answer. So maybe it's fun. But anyways, so Systems in Rust, I was putting their final together, and I realized they should use JSON for everything. Now, you have seen JSON in Python, and when I showed you JSON in Python, I was like, hey, this thing is also used in other languages. And you were like, sure, buddy. Okay, bud. For real. Right. No, I believe you, right? So, lucky us, I happen to have a folder here on my computer called For JSON, which is from another class where I'm teaching a different programming language. And would you look at this? It's JSON from a different programming language. You're under no obligation to care about this, but I thought it was pretty interesting. I'm going to do a little bit of terminal-style stuff, and I'm just going to show you what this looks like in another language. I think it's good for you to be exposed to this, so I'm taking a few minutes at the beginning of class. What I'm working in here is I'm working in a folder, and I'm working at the command line. If I type ls, it will list the files in my folder. So I have something called a cargo lock, a cargo toml, helium.json, which is the JSON file we can look at. And I will show that to us. Does that work? Okay. JQ stands for something query. It's either JavaScript or JSON. I don't know why you have to put a dot there. Maybe you don't have to put a dot there. Okay, that didn't work. So for some reason you have to put it out there. Do I know? No. But anyways, this is the same JSON file I showed all of you in the JSON example when we were introducing it for Adventure. And I just wanted to play around with this in the other programming language. The presence of things called cargo in here, you're under no obligation, or you're not even necessarily encouraged to know this. Cargo is affiliated with the language Rust, which is an up-and-coming language people are excited about. I wasn't a huge fan of Rust. Actually, students encouraged me to teach Rust this year, so that's why we're teaching Rust at this university now. And in a sort of, when you're writing Rust code, I do it at the terminal. And one of the things it works is there's a little folder there called source. That contains your source code. Goodness me. I haven't spoken for 5 days and I forgot how to use words. That's not true. I talked to my family. Hope all of your families are doing well. Okay. So that's main.rs. That .rs is the same thing as .py. That means that that's a code file. I'm going to open this up with a text editor based in the terminal and just show you what it looks like. No, I'm not. That's wrong. It's in source. I can't spell. Pretend you're not seeing any of this. Okay. Wait, what? No. First try. Okay. So, the first thing to note about Rust, and in fact, many other languages that are usually used to write big projects and software, they're much more verbose. So you have probably seen Python code that does exactly this because I showed it to you in class. but there's a lot more stuff in here. So first of all, we have on the first line something that is a lot like an import statement. Instead of saying import in Rust, we say use. And so I'm using a package called certa.json, and from that package I'm using the JSON, map, and value subpackages. Map is very close to Python dictionary, and value is actually very close to Python values. In Rust, every value must have to have some type. In Python, they do not. So in order to create JSON, we have to have stuff that can be any type. That can be a string or an integer or a list or a hash map. So we include value. So this is sort of allowing us to do some Python-like things. In Rust, all of the code must be included in something called main, the main function. This is a little bit true in Python. You've seen the boilerplate that says, like, if something double underscore equals main. Do you remember this? It's like, that's sort of the same idea as what we have here. This line probably looks horrible, right? That is the same line as just creating something called any that is equal to an empty dictionary. So that is the same. I'm going to type it out here. Oh, there's giggles out there in the hall. That's crazy. People shouldn't be happy right now. Okay. Those lines are doing the same thing. In Rust, the language is trying to protect you from doing things you don't mean to do by accident. And one of the things it's trying to prevent you from doing that you might not mean to do by accident is putting different kinds of types of things in your keys and values. So this right here forces all of your keys to be strings. This right here forces all of your values to be the special value type, which, okay, we can debate the merits of that. And then instead of putting two brackets here, this specifies that I want a certa map, and this is the map that is good at holding JSON. There is separately also something called hash map in Rust, which is also the same thing as a dictionary. This isn't totally unusual. There are, for example, ordered dictionaries in Python, I think, that you can get access to somehow. So most languages have more than one type of dictionary. And here I'm having to explicitly specify the type of dictionary. Let's step back over here a little bit as well. So this just means this is the type of thing. And in fact, it is well-formed Python to put in type hints as well. They're just not required in Python. And I think I can say, like, I think that is still well-formed Python, and it's sort of getting a little bit closer. You are allowed to put semicolons at the end of your limes. Limes? Okay. Anyone have any lime recently? I feel like it's not really lime season.
No, I've only eaten Thanksgiving food for like the past.
I've had lime flavored soda water.
There you go. Still counts. Okay. This here at the beginning, let and mute. It is quite unusual among the programming languages that Python doesn't require you to put anything before a variable declaration. In JavaScript, you would say let, for example. And then separately, most programming languages both have variables and constants. Putting mute here makes this mutable, which means it's not a constant. So all of these things here are specifying stuff that is just unspecified in Python, and there's pros and cons to that. I like Python for writing things quick and getting anything working at all, and then I like Rust when it actually has to work, right? They just solve different problems. This operation here, and I have many of them, that's the same as saying any symbol equals any. What is sort of changing about this? We have to say dot insert instead of using the sort of selector notation here. We have to turn this text into the actual string type. There are multiple string types in Rust. I hate that. I've been assured it's good. And then over here, typing JSON on this, that's the same thing as if we take, we turn a tuple into a list. So we're turning gas into a JSON value. So this one So these are both text, right? But this one is magically a string, and this one is magically a value. But when all of this is said and done, what do? I add 4 key value pairs: symbol, phase, group, and period. Then I create a new, it's called a map here, but it could be a dictionary, and it corresponds to boiling point. And then I add the Kelvin, Celsius, and Fahrenheit boiling points. And do I include decimals? No, because I love integers. And then I insert the boiling point thing after it's turned into JSON. And then this prints things out. DBG stands for debug, so it's the debug form of print, so it will give some diagnostic information as well. So this is the code I'm looking at. We can save and exit that. And then in Rust, instead of saying, for example, Python circ main.rs, you can say, I think, Rust C or something, but usually the way you run Rust code is you type cargo, run. Cargo is attached to Rust. And when this runs, we get a debug print. So this helpfully tells me what line the debug is at. Really like that. Would really like to have that in Python. Right. I write what line number I'm at inside a print statement a lot in Python. And big software engineer might talk to you next term. They might teach you to use a debugger. Don't fall for it. Just print line numbers. I'm not allowed to say that. Fall for it. And then unfall for it after the course. And then don't blame me. Okay. And it also says the name of the variable. And it just prints this out as well-formed JSON. And so we can see that these things are basically the same. Now, JSON is not ordered, or specifically the JSON dictionaries, which are called JSON objects, are not ordered. So these are the same thing, even though they're in different orders. And then these are just labeled as strings and numbers because this is not meant to be written to a file. The Rust programming language is keeping track of whether they are numbers or strings. Anyways, Rust is popular. A lot of cool people are into writing Rust these days, so you might see some around in your life. There you go. Mergesort. Okay. I would want to be done with adventure by now, but that's just me. We for sure have no questions about adventure. Okay. So I've been hearing, someone's been going around saying adventure was too easy. Was that one of you? Okay, someone was going around saying it was too hard. Was that one of you? No one was saying anything about adventure at all. We have no opinions. Okay, that's what I like to hear. I also don't have any opinions. There's also advising happening. Oh yeah, adventure's due Wednesday at midnight. You all know that? Okay. If you need help with advising, don't ask me in class. Ask me after class. I'll be like trying to leave so I can like go get a bagel sandwich somewhere, right? But I would rather talk to you than have that bagel sandwich. So just grab me after class. I'll have high blood sugar and everything. Okay. Today we're gonna do things fast again. Yeah, I don't know. I've been driving around during like Thanksgiving traffic, right? And that hasn't convinced me that going slower is better. It's convinced me that there are many people that are unsafe at any speed, right? And am I one of those people? Who's to say, right? So this is again, this is not about adventure. This is just classic CS1 stuff we'd like you to know. And so what we're going to do today is we're going to do some sorting. You all remember Wordle back in the good old days? Yeah. How I miss you, Wordle. Let's go ahead and do the Wordle real quick. What else are we doing? Has anyone done it today? Oh, is this going to spoiler all of you? I'm going to do my first 2 guesses, and then someone else can shout it out. Oh. Ooh. Okay, who has a word? I'd sure like to know where that A is. There's like no consonants in this. Is womp a word? Oh, that doesn't help, because we have the P already.
Heart? Well, the T, no, the T won't work.
We can do...
Heard.
Okay.
Try it. See what happens.
Okay. All right, not bad.
I think there's an H in it.
I bet it ends with an H, right? It's like... It like is quite likely to end with a CH, right? Beach, maybe? Ugh, that was the only thing I think of that started with that.
Leech with an L.
Leech with an L? I know how to spell leech. Haha. Good job, team. Okay, anyway, so that's Wordle, right? And that's basically what we're doing today. Okay, so, you remember one of the things that Wordle contains is words. I believe that's why it's called Wordle. I don't know where the L comes from. Puzzle? Okay, now I know. Okay, that was very straightforward when I thought about it for an entire second. So previously we were checking to see if we had some words. When we did that was with binary search. You remember? This was my peanut technology. So I checked in the middle of the word list to see if the word was before or after that. And then I kept cutting the word list in half. And so this was many times faster, is in fact hundreds of times faster than any other way of checking to see if there was words in a word dictionary. Right? That was cool and good, but it required the word list to have been sorted. So here's the problem. What if you want to sort your peanuts by height and you just bought 40 metric tons of peanuts, right? And as a simplifying assumption, we're only going to do 20 metric tons of peanuts. So actually this is much easier. Sorry, it was 20 metric tons of peanuts and 40 grinders. And as you all know, it's very important to eat the taller peanuts first because they've had more time to grow to that size. And you don't want to start eating the small peanuts because you want them to continue to grow to full size, right? This is basic forestry, right? So if any of you are looking at a career in forestry, always eat the tall peanuts first, right? But in order to know which peanuts are the tallest, you have to sort them by height, all right? And so the way I do this, and I do this every time I buy 20 metric tons of peanuts, is I take one peanut and then I set it down, and that forms my array of list of peanuts by height, right? And then I take one more peanut, and then I look at the first peanut, and I see if it's taller or shorter. And if it's taller, I put it in front of that peanut. And if it's shorter, I put it after this peanut. Are you having fun yet? Okay, then I take the third peanut, and I look at the first peanut. And if the peanut I'm holding is shorter than that, I put it at the beginning. But otherwise, I have to check the next peanut. Yes, this is my favorite sorting algorithm. So what I do is I look at every single peanut and I compare it to every single other peanut one at a time. But this is very hard on my eyes. They get watery after a while because I also don't blink while I'm doing this, right? Because if you blink, the blinking might cause diffraction on the light, which I'm making things up. Don't listen to me. Okay, don't blink. I also don't blink while I'm driving to Thanksgiving dinner. Fun fact. Okay, so I do this with my 20 metric tons of peanuts, and I refer to this as having a good time. I've invited my friends to do this with me, and none of them have ever wanted to come do it. So I think that my friends probably don't like me and also hate fun.
It's so useful to have friends because when you have to put a peanut in the middle, you have to move all of the other ones one peanut over.
See, if you're really thinking ahead, you just leave enough space after every peanut for every other peanut.
Okay, but like...
This is also a good way to get your steps. Yeah. I actually use a train. So yeah. I have an old abandoned subway line I use to sort my peanuts, right? But it's important to eat the tallest ones first, so we have to do it. A lot of people think using a coal locomotive is more environmentally costly than just eating the smaller peanuts first, but I never checked. Okay, so sorting peanuts one peanut at a time by comparing to all other peanuts is technically correct. This will in fact get you all of your peanuts in the correct order, right? However, this is bad, right? And so, fortunately, we've already learned that sometimes there can be ways of doing things that gets the correct answer that are still so painful they are nevertheless incorrect. And so now we're going to talk about the correct way to sort your peanuts by height. But first, let's write some code. Suppose we have a peanut and an ordered collection of peanuts, okay? So we have peanut and peanuts. This is sort of I'm going to put this in VS Code because it might be a little more readable. We all love VS Code, don't we, folks?
That's the trick.
Does it? Or, yes, we love VS Code. Yay. Okay. Peanuts? Surely that's not taken. Okay. All right. So we're going to take a peanut and we're going to add it to peanuts. We have the index. We're going to start looking at the 0th peanut, and then we're going to progress through. As long as the current peanut is smaller than the indexed peanut. Why did I put index here? Because I is too hard to read. So I'm just writing out index. I'm going to see if my peanut's taller. Why would... Did you notice when this thing was open, did you notice it didn't give me any notifications? I'm just pointing that out. Okay. Thank you, Microsoft. Okay. Sometimes if you say thank you, Microsoft, it waits longer before it bothers you again. Okay. I increase the index by 1. And then when I find the location where the rest of the peanuts are taller, I take the peanuts before that location, I add the peanut, and then I take the peanuts after that location. So we can probably do this with an example. I'm going to stretch the truth here a little bit. I'm going to pretend we can represent the heights of our peanuts using the integers. Right? I know. I didn't want to do it either. So maybe we'll have some peanuts, and they'll equal, and these have to be in order, by the way. So maybe we have like 2, 2, 3, 6, 7, 8, 9, 50, right? And that's the one that's full grown and you can eat it, right? And then I'm going to insert a peanut, and it's going to be 4. And then what am I going to do? I'm going to say, well, I want to add peanut. And I'm going to add peanut to peanuts. And that's going to be my new peanuts. And I'm going to go ahead and print that out. And we're going to look at this closely using our own eyes and see if we think that we have successfully put this peanut in the correct location. Oh. Hold on, I have a plan. That wasn't a list. Oh no, it's only 4. Is there a disaster? What happens if I just get rid of this? Oh no. What have we done? I'm going to look at peanuts here. Presumably this code didn't work last year either. Wait, what's the index? The index is 0? What? I'm outside of the what? We think it's different in here. Sure wish I had a debug statement that said what line that was in. Whoa, it's just not running at all. Do you see that?
Yeah.
Boop, boop, I'm a loop. This is what we're reduced to. Okay, so for some reason peanut is less than peanut's index. Is 4 less than 2? Am I not good at counting?
Or is greater than 2, so
You could print peanuts out index.
2.
Is this what I want to do?
Yeah. Okay, no.
I was sorting them from... Wait. That's still bad. I checked these slides last night, but I don't even know why I look at them. I can't tell. Okay. All right. After thousands of years of arduous struggle, we have successfully added 1 peanut to our group of peanuts, right? But I know what you're thinking. You're thinking, shouldn't you add an additional peanut? Perhaps a peanut of size... I heard a 7. Okay, that's not true. I didn't hear a 7. I'm telling lies. Okay. Let's do this again. Uh-oh. There we go. We can keep adding things. And look, now there's 2 7s in there. Oh, so this is staying in order. Pretty cool, right? So that's cool. Bet it could be cooler, right?
What's cooler than sorted peanuts?
Sorting peanuts quickly. So if we take all of our peanuts and we want to put them in order, for example, who wants to come up with a list of arbitrary numbers in no particular order? We could use random, but then I'd have to remember how to do it. Well, okay, no, hold on. We're import random. Random dot shuffle. Does this seem like it might work? Oh no, I'm going to print all this. It's going to print literally a bazillion. Let's see. Does not support item assignment. I have a plan. None.
Because what shuffle does is it just,
It's not doing it in place.
An existing list.
yeah.
Fine.
You can do rand range with a limit.
Oh, okay. How do I do that?
Rand range in parentheses limit. Or whatever the limit is.
That's probably fine. Wait, that's only one value. It's a different value every time.
So make a list of all of those different values.
I think this is going to work. Why? Okay, I love VS Code, right? I just want to quickly scroll to the next line of code. Okay. I love VS Code. Okay. Yeah, okay, that's a random list. I'm proud of myself. Okay. And how many of them are there? Some large number, 10,000 or 100,000. Okay. So what do we have here? And who knows if this code works? I sure don't. Okay, so we can order our peanuts. What are we going to do? We're going to take the very first element of the peanuts and we're going to put it in our list. Then we're going to loop over all of the peanuts. We're going to start at the first index. Well, the index is less than... Oh, we're making sure we don't go off the end, because if we go off the end, we have to insert it at the end. Okay. And peanut is greater than the ordered index. Greater than. We're going to increase the index, and then we're going to insert the peanut at that location. So I'm just using dot insert here instead of this, because this is extremely ugly. We can all agree that this is the ugliest thing we've ever seen in our lives. After the feature film Coyote Ugly? Maybe? No? Okay, all right. I'll keep trying in case I get something good someday. Okay, so let's take our peanuts. We printed them out. Let's go ahead and say new peanuts equals order peanuts. Wow, I've written peanuts so many times today, but still fewer than the 20 metric tons would have you expect to believe, right? So this is still more efficient, no matter how many times. Okay, I bet this one will be sorted. Is that doesn't? Oh, it's still sorting. See, it's going slow style. I wonder if that's because it's comparing 100,000 things all to each other.
Uh-oh.
Does that seem like that would be slow? It's a computer. Computers are fast.
How if you make them do 100,000
Maybe we should
things?
use a not in script sorting out.
I think you should stop doing spoilers. It's very fast with 1,000, and this is definitely in order.
You didn't print the new.
Yeah, you're still just...
Oh, not to worry. I have an ingenious plan. I'm going to print the new one. It is both bizarrely harder and easier to code with all of you here watching. I just want you to know that. Oh, okay. That looks in order.
Awesome.
It happens to be all of them just because I took a range, so it's exactly all of them. But we don't have to do all of them. We can take every third one. I don't know why we do that. Oh, that was slow already. Okay, let's count. 1 Mississippi. Okay, it's exactly 1 Mississippi away. Now, the Mississippi is larger than the Columbia, but it contains less kinetic energy because it has less drop over its length, right? So really, who's to say the Mississippi is the larger river, right? I think it's the Columbia, because I measure my water in kinetic energy. Okay, so maybe this is bad, right? Because in 20 metric tons of peanuts, you are quite likely, but not certainly, going to have more than 10,000 peanuts. Okay, so we can split the peanuts up into different grinders. Remember when I got my 40 grinders and ground all of the peanuts at the same time, right? So I'm going to take a pile of peanuts, I'm going to divide it in half, then I'm going to sort both halves, and then I'm going to combine the halves. Seems pretty easy to me, right? I love taking piles of peanuts and pushing them into two halves, right? So we've probably all done this. Also, fun fact, if you're like hanging out with like one of your nibblings over the holidays, right? So like all of your siblings are having children, right? This is not just me in my 30s, right? And like they're like, hey, can you entertain this 4-year-old? Sorting 20 metric tons of peanuts can entertain a child for a very long time. And then other fun fact, you can just ask them how fast they can run over and over again, and eventually they'll be tired. Okay, so we're gonna take a pile of peanuts. We're gonna call this one's now gonna be named Old Style. It's named after the Oldsmobile. We're gonna make new one. Okay. Am I clever enough to do this? Okay, there we go. We're gonna divide and conquer, and that way we are much like. Okay, I'm going to say one thing, don't put this on the course of ales, the CIA. Okay, all right, we're going to divide and conquer. So let's take our order peanuts, def order peanuts. Okay, I'm going to divide it in half. So how am I going to do that? Well, I'm going to find the middle of my pile of peanuts, which is the length of peanuts. Now, silly gooses will do this style of divide, right? And that style of divide is against the law because that returns what kind of number?
Float.
The wrong kind of number, right? So we're going to get the correct kind of number. Right, okay. When God created the heavens and the earth, did it take 7.0 days or 7 days, right? So don't blame me, right? Okay. All right. We're going to take, and it is true I'm getting into my name all of variables names that happen to be the same length era. So we're going to have a head, which is going to be the top. That's going to be the peanuts up to the half. And then the tail is going to be the peanuts after the half. If I'm making sense here. Wait, what? Head is underlined because I haven't used it yet, so it's perceiving it as an error. Oh, maybe it's this thing. Psych, I was completely wrong. Did you know that the whole time? Were you testing me? Did I fail? Am I failing CS1? Okay. By the way, I looked at the average grades this turn. Y'all are cooking. Keep doing whatever you're doing. Okay. I am definitely not taking credit for that. Okay. So, all right, we divided our peanuts in half. Now what do? Now we simply sort both halves, right? And fortunately, I already wrote a function that sorts the peanuts. It's called order peanuts. So I'm just going to say head is going to equal order peanuts of head.
Defining order peanuts right now.
I'm cheating. To understand this, you first have to understand this. Okay. Then all I have to do is I have to take the head and the tail, and I have to merge them back together. So we have to go merge style. Now, merging is near and dear to my heart because I just drove through Thanksgiving traffic and I found out that not a single soul living in the entire municipality of Portland knows how to merge. And then I drove down to Salem. Do you, like, people kind of know how to drive down here? It's like, I feel like my life is less in my hands the closer I get to the state capitol. And then you get really close to the state capitol and it's in your hands again, right? Like, okay, so we're gonna return this, but first we have to put them together. We have to make them be friends. So we're going to go ahead, we're going to merge our peanuts, right? We're going to merge the heads and tail. Oh, no, I got a squiggle. That means I have to write merge peanuts myself. Oh, that's more work for me. Okay. Do we need a stretch break? That was a trick. No, grind harder. Okay, so I'm going to take the two piles of peanuts. I'm going to push them apart. They're magically going to become sorted because I'm writing the function that's sorting them. Right? So if I write it correctly, then it'll be correct. If it's correct, it'll be correct, right? And then I'm going to take my 2 piles of peanuts, and I'm going to look at the first peanut in each pile, and I'm going to see which one's sorted, and then I'm going to do this, right? And I think it's obvious what I'm doing here, so I'm not going to bother to explain it with words. Okay, so let's go ahead and write merge peanuts. I sure hope someone wrote that on the next slide. Oh, thank goodness. Okay. So we're going to take a head and a tail. Well, yeah, we'll call them head and tail. Not too bad. So I'm going to create a new list. I'm going to call this merged. I'm going to call it merged. And it's going to begin with no list at all. No list at all. That's crazy. Why am I doing that? Because I'm going to put things from both peanuts into it. Okay. Then I'm going to check to see if there are peanuts in head and peanuts in tail. And I can do that by just saying head and tail. I know you don't believe me. So the empty list is treated as equivalent to false. So once I get everything out of a list, it's treated equivalent to false. So I can say, for example, I'm going to call it R instead of list. So this is for array. We're going to take a list of range 10. There's R. And then I can say, while R, print R.pop. That'll totally work, right? And so I don't know if you write your code like this ever. You don't have to. I had to write the code somehow, so this is how I'm writing it. Okay. Geniuses will notice that that's popping from the tall side. That's sad. Okay. Because I like thinking about it from the small side. So what am I going to do? I'm going to check to see if the first element in the head list is greater than, I guess less than, the first element in the tail list. Now I want to put the smaller things in merged first. So if head is less than tail, I'll take merged. Why did I take out the vowels? And I'm going to put head 0 in there, I think. Is that what the answer key does? Wow, that's crazy. I wrote the same code twice. Okay, so does this look extremely ugly? Do we hate this? Okay, we hate this? Okay, I think this is allowed. I don't know if we like methods better.
Not depending.
I'm working on it. Okay, all right. Cool. Yeah? Do we like that better?
I kind of like the plus equals, but append is good too. You don't have to change it. It's okay.
It's too late. Not to worry, I have a plan. We'll just use both. All right, it's just,
Yeah.
it's all good, right?
Variety is the spice of life.
See, and I thought this whole time it was pumpkin spice was the spice of life. No, but it turns out to be variety, right? Which is why pumpkin spice is seasonal. Okay, so this is pretty well and good, right? And this will continue until I deplete one of my lists. But there could be a whole bunch of peanuts in one of those other piles. So I'm going to add them all together. Merged. So this is all of the stuff that I took from the beginning as the first lists. Now either head or tail is empty. And head and tail were sorted when I got them. Which means I can just add head and tail to the end of this. One of them might still have some elements in it. I don't care. But all of those elements will be in order.
Are you pulling things out of head and tail every time you add something to merge?
Yeah.
Because it seems like that's what you're trying to do, but I don't see what else.
I don't know how to do that. Oh, I was updating it here. Is there like a head... oh, wait. No, I don't have any brilliant ideas. This code's going to be slow. Wait a minute. Do I have to do it this way? Can't I do head pop 0? Okay. Right, okay. while r print r.pop0. Okay, that worked. Why did that work? I would not thought that would work. Okay. So instead of saying, we'll pop 0 it. Does that fix the problem you saw? Okay. Where we print? Do I have? Okay, peanuts are randomly shuffled. Okay, we got old style. Got merge peanuts. We got order peanuts. Okay. So we're gonna say new peanuts points. What am I doing? Order peanuts. Peanuts. Did I write peanuts 3 times on that line? Have I? Do people still say jumped the shark?
No idea what that means.
Okay, that's an AI overview, so that's lying.
The font.
It's just a dream.
By the way, you shouldn't feel that terrible about giving money to Wikipedia. It's one of the only non-evil websites on the internet. But really, you should talk people with more money than you into giving money to Wikipedia. Right? Okay.
It's true.
It means that a creative work or entity has evolved and reached the point where it exhausted its core intent and is introducing new ideas that are discordant with okay. I think that's what we're doing, right?
I feel like we're not introducing any new ideas, though. It's still just peanuts.
My maximum recursion depth exceeded? Crazy. Oh. Can I do even 10 of them? It seems like I'm probably doing something wrong, wouldn't you think?
Yeah. I don't understand.
Ah,
You-
I figured it out. We're trying to do this to empty lists an infinity number of times. Not to worry, I have an ingenious plan. If length of peanuts less than 2, return peanuts. Okay, that works pretty well. Wait, was that way faster? Oh, it's still slow. Oh, that was okay. That wasn't that bad. That was not that bad, right? My guess is 10 seconds. We'll see.
Oh.
We're sorting 1 million integers. Why? What else would you use a computer for? This is what computers are good at. Or apparently, I thought they were.
Pretty good.
Better than me.
You're taking a while.
This is probably still not enough to do 40 metric tons of peanuts, right?
No.
We should look up how many peanuts is 40 metric tons.
That's a good question for ChatGPT. Let's drain a reservoir.
Oh, no.
We'll stay logged out, so... Okay, fine, we won't ask
We'll stay
ChatGPT.
logged out, it
Who,
doesn't mean
who,
anything.
who do you want to ask?
Are the peanuts still shelled, or are we?
Are the peanuts
Because are like.
still shelled?
So how
Or-
hungry are you and how long are you willing to wait for your peanut butter?
Are we shelling them? Oh, so I do this continuously. This is like my life story. You know Sisyphus, who pushes the boulder up the hill? I make peanut butter sandwiches. So I always have some around. Okay, we may have cooked a little bit too hard here.
And you don't know if they're unshelled or not.
After grating, the peanuts are sent to be shelled. So they'll be shelled after final grades are due and not before then. Okay, that's pretty cool.
I feel like you do have to shell peanuts before you can grind them, right?
Not if your grinder's powerful enough.
I don't think it would be as delicious if you
You
had a
don't
bunch
like
of
shells
peanut
in your
shell
peanut
in
butter?
there. No,
Yeah, that's how they make crunchy peanut butter.
I don't think so.
It has that extra.
I don't think so.
Also, it's very high in fiber.
Maybe too high in fiber
Maybe not high enough. Right. Okay. So,
for a guy like me.
some of you love science, right?
Yeah.
Science rules, right? Bill. Okay, right? Yeah. A lot of people don't know this. Bill Nye is actually short for Silly William Nye. Yeah. Okay. So, what am I going to do? I'm going to compare old style and good style. And the way I'm going to do this is an ingenious technique known as counting, right? And so what I'm specifically going to count is I'm going to count how many times I do specifically this operation. I compare a peanut to the height of another peanut, right? So I do that here, and I do that here. So let's make something. We're going to do compares. And initially, I have not compared anything. And this is going to be old style and then good style. Now, I don't take this out of context. I'm not saying things that are old aren't good, right? Remember the lectures on the Alien franchise, right? Okay. So don't take this out of context and clip it and send it to people that are old saying that I'm saying they're bad, right? Send this to Ridley Scott. Okay, so what are we going to do here? Compares 0 plus equals 1, and then down here we're going to do compares 1 plus equal 1. Okay. Should probably get 2 copies of peanuts, right? So we're going to get some peanuts for old. And how are we going to make a copy of this list? So I want 2 copies of why is that? Because I want to sort the same list, right? Obviously, right? But I can't sort it twice because once I've sorted it, it's sorted, right? And by sorted, I mean this word. Involving ignoble actions or motives arousing moral distaste and contempt, right? And so I don't want to deal with anything that's sorted. So I'm gonna make an exact copy of this list by taking a slice of the entire list. Whoa, it's so brilliant. Oh, it's so cool. And your haters will want you to do this, right? Don't listen to your haters. Just go slice style. Okay. So let's go ahead and we don't need to print anything. Or we'll print compares when we're done.
There are probably around 50 million peanuts in 20 metric tons.
Okay. Okay. That's only, I'm only going to do 10,000 now because we're doing old style.
All right.
New peanuts for old equals order peanuts old style peanuts for old. Do you remember how long it took last time? Did it ever finish? Do we need to go down to 10,000?
Let it finish.
You didn't let it finish? Call me Kanye West because I'm not letting it finish. Don't remember that I said that. Okay, all right. Peanuts F is not defined. Just the amount of adversity I face in my daily life. Whoa, those numbers are different. I bet that was an error. We'll test it again.
That's really funny.
Printed 2 different but similar numbers.
Isn't one of them really close to the number of peanuts squared divided by 4? And isn't the other one really close to the number of peanuts times the log of the number of peanuts?
Wow. I wouldn't know. I'm not able to do that in my own.
I learned about log like once when I was in high school, so I don't know.
We're in the Pacific Northwest. You have to know about logs. It's a big part of the industry here. Okay. So the thing I'm noticing mostly is that this looks an awful lot like a quarter of something that's a power of 10, right? And so I just count the zeros here. That's a 3. That's a 6, right? So this is That's a quarter of 10 million. 100 million, thank you. And that is 100,000. Let me get out my calculator here. Wait, there's a calculator? Stop listening to what I'm saying and instead listen to the numbers that I'm putting on the screen. Okay. So you got 10,000, right? And if that's squared, that's a big number, right? Hold on, let's line it up. Are those numbers about the same number?
Yeah, I think we.
Okay. And that would make sense, because this is if we compare all of them. But on average, you actually only have to compare the first half of each, right? Because sometimes you'll get things that are close to the beginning and sometimes to the end. Okay. And then what's this number? Well, that's pretty close to this number, right? Go ahead and hit a copy paste on it. Okay. Why do I have sorted up? Must have been doing a bit. Okay, so that's not the same number of digits, right? But I think there's something called a log. We're not yet in the Pacific Northwest. So in Python, the name for the Pacific Northwest is numerical Python. So if you're ever in the Pacific Northwest, you just type import numpy as MP. This is true story, okay? And then you have mp.log there. See, right? There's a log, okay? And if we take the np.log of this much, it's about 10. That's not the right number of zeros, but we're getting there, right? Oh, there we go. You just have to take the log base 2. So, why is that? Okay. Not to worry, I've got you. So, here, this loop, on average, we are looking at every peanut that has been sorted so far. The average length of that list is half the number of peanuts we have. Because when we start at size 0, when we're done at size all of the list of peanuts, right? As we go through that list, on average, we will go halfway through that list to find out where to put our peanut. So on average, we do half of all of the peanuts. So on average, half of all peanuts. Okay. Now, where's the other place we were adding? Right, okay, right here. So, how big are these things? Well, we can calculate how big head and tail are, because the first time we split things in half, they're half the size of the peanuts. And then we do a merge on those two halves. And then we do a merge on the halves of those two halves, but we do 2 merges on it. So we're sort of weighting by how short the list is. So we will merge a list of length 2, the number of peanuts divided by 2 times, and then we will order a list of, I'm thinking here, my brain started hurting. We will merge a list of half the length of the total of number of peanuts once. So, how long is this on average? Well, you have to do calculus, but it's a logarithm, I'm sorry. So we're going to hit this with it's a log, trust me. Okay? And I wouldn't lie to you about the Pacific Northwest, right? This is where I'm from. This is not where I'm from. This is where I live by choice and not just because only the job market here was solid. Okay. So, if you do this experiment at home, you'll get pretty similar results. Apparently going one at a time is 211 times as much work. I think I could handle it. I think I could do it. I think I could sort all of those peanuts. And here's the full code if you want to try it at home. Let's make sure this actually works. Because I don't want to tell you you can try it at home, and then, you're like hanging out with the family and then it explodes or something. Oh, that number is way too big. Wait, no, it's not. That's fine. See? Oh, I bet we can do it again. Yeah. Yeah. we're sorting peanuts, right? Okay. So today we did things fast. It's not adventure relevant. We have 5 minutes. You're sure you don't want to ask me anything about adventure? Do you want to go on an adventure? We can go on an adventure to the Pacific Northwest and look at a log.
Sure.
Okay. All right. I think... Didn't I teach us about time last time? Well, that's a lot of code. Are you singing Pink Floyd?
No, it's time by reading the book.
Okay, that's fine. As you were. Okay, let's do this. All right. We're going to start time. F is going to be... this is too exhausting. I'm just going to do it all manually. Wow, this is exhausting. We should also see how fast this is, and there's a reason to see how fast this is that I will reveal in one moment. Okay. Print. Did I fix what you said? Okay. That is not a difference of 211, by the way. This code is atrociously slow because it's making and destroying new lists all of the time. The totally awesome way to do this is to make one list and just keep track of indices in it, the same way we did the index management with binary search. I need to be re-scrambling peanuts every time. Hold on. Built-in sort is probably going to be a lot faster than this. So there's your well over 211 times faster. The built-in sorting algorithm does not create and destroy new lists all of the time. But, teasing a future term, if you want to go a couple hundred times faster than that, you can just write your code in Rust. All right, okay, that's all I'm allowed to say today. Thank you. I will see you next time. Just so you know what we're doing in future classes, I'm going to teach you about the kernel, or the terminal-based text editor, and I'm going to teach you about the command line. And that's because that's what my CS1 professor did when we ran out of material at the end of the term. So I have historical precedent.